Next is the power spectral density of the qpsk. Here on the power spectral density we are considering the two observations, that is one is phase and another one is in phase depending phase component one, and other one is depending upon the debits, that is in the depending on the debit sent during the signaling interval, that is t varies between minus tb2 to plus tb2. The in phase and the quadrature components of the g of t denotes as the symbol shaping function, that is g of t is equals to square root of e by t, that is t varies from 0 to t. Hence we have in common power spectral density, namely E is equals to namely E into sine square of Tf, where S of f is equals to Vb square into Tv into, this is a sine function, that is sine pi ftb by ftb. This is a power spectral density. Okay, and consider this is a power spectral density of an even function is given by the Vb square Ts into sine fts by pi fts into whole square, and one more, this is a sine function, odd function, so Vb square Ts into sine pi ftbs by one is for sine and another one is for odd. So the for the power spectrum of an even function, that is b e of t is equals to b b0 of t, that is odd and even, both are the same bit duration. So given as a 2 tb here, for in 2 tb seconds only we are considering. And next is the in phase and the quadrature components are here in the statistically independent, that is the baseband power spectral density of the qpsk signal is added to the sum of the individual power spectra of the in phase and the quadrature phase, that is sb of f is equals to, we are adding two components, that is even and the odd, that is in phase and the quadrature phase. Therefore Ts is equals to 2 into Tb. Here the Sp of f is equals to 2 into Vb square into Ts into sine pi fts by pi fts into whole square, here Vb square. This is doubles the power. So finally we will get Sbf of f is equals to 4 Eb into sinc square, that is sine square. This is standard, that is a Fourier transform. So 4 Eb into sinc square into f of fts. Look at here, we will get an E 2E, that is V square into Ts can be written as 2 into Eb, therefore V is equals to square root of 2 Eb by Ts. So we will get an, if you multiply these two, that is multiply square, we will get a 2E. So here we will get a 2 already there into 2, if we multiply is nothing but a 4. Here we are considering the bits, that is 2 bits, so E is this, so we have written a EB sinc square FTS. And next is this is a power spectral density of the QPSK and MFK signal. Consider this, look at this signal, there is a ripple, and for a normalized power spectral density, this is for 4 bit, and for 0 we have a 1 in the QPSK, where for an MSK, that is the minimum shift gain, we will not get a 1, that is the amplitude gets reduces here in the normal frequency, but there is a ripples in the output. And consider there is a offset of a QPSK. Here in the QPSK, how it will changes is nothing but the carrier phase changes by plus or minus 180 degree, whereas in phase and the quadrature components QPSK is signal change sign. Signal change the sign, that is when the input binary sequence switches from the debit 0 to 1 to debit 1 to 0, it changes 1, and other one is the carrier phase changes by plus or minus 90 whenever the phase in phase and the quadrature phase changes. That is example, when the input binary switches from the debit 10 to 00, in that phase the in phase component changes, that is, whereas the quadrature component is unchanged. That is, this is in phase, this is quadrature. Consider this is the in phase is changed and second term the 00, this is quadrature is unchanged. And the third point is nothing but the carrier phase is unchanged when either the in phase components or the quadrature components changes the sign. That is, when debit 10 is transmitted in the two successive symbol intervals, the 180° and 90° phase shift in the carrier phase can result in a change over of the carrier amplitude during the course of the transmission over the channel, causing additional error here. And to reduce this, we will go for an offset qpsk. To this end, the quadrature components is delayed, that is, the offset by a half symbol interval with respect to bit stream responsible for the generating in phase component. That is, phi 1 of t is equals to square root of 2 by t cos 2 pi fct, where t varies between 0 to t, and phi 2 of t is equals to square root of e by 2 sin 2 pi fc of t. Here the duration is from t by 2 to 3t by t2. So advantages of the qpsk: for the same bit error rate, the bandwidth is required by the qpsk is reduced to the half, that is compared to that of the bpsk, and because of the reduced bandwidth, the information transmission rate qpsk is higher, and the variation in the qpsk amplitude is not much, hence the carrier power is almost remains in the same. Next is the qpsk waveforms. Consider here this is a binary stream as a 01101000. For the input binary sequence, we are considering that is 2 bits as a 1 debit. This is 01 is a 1 debit, this is 01, and 10 is 1 debit. 10 is 1 debit. This is for sequence they are given, that is 01 1 0 1 0 0 0, and for this we have split the odd numbers event and the even number event. Odd is nothing but a 1 2 1 3 5 7, like that. Even number is 2 4 6 8, like that. So here 0 represents first written the odd number is 0, first bit 0 1 1 0. So 0 is nothing but a minus sign, 1 is positive sign, 1 is positive sign, and 0 is negative sign. So we are written, and even number also we are written, that is a 1 here 1 0 0 0. 1 is positive sign, 0 negative sign, negative sign, negative sign. Here the s1 of the odd number is multiplied with that of a cos function. Cos function is like that, is like this only. Even function is nothing but a sine function. Here normally sine function is like, here for a bit 0 is there, so we have a negative bulb. So cos wave starts with a negative up to 1 bit duration. This is 1 TB and this is 1 TB. Consider 2 bits, no? So we have 2 TB. So 1 TB. Here next 1 is there. So we will not write from here. We are writing, we are starts from this to this only. Next here 1. So that is the symbol 1 positive only. So same thing positive. Next the symbol 0. So 0. It starts in the negative. That is odd number sequence. Next is the even number debits. Even number debits is multiplied with that of a, that is, we multiply these signals with of sin t. Sin is usually the positive plus is there, so positive cycle up to here, and again for 0 it is negative, so negative 1 duration. Here it's a negative, again it's a negative sign only, so again here negative and here also negative, so negative. Next, s of t is nothing but an addition of the si1 of t, phi1 of t plus si2 phi2 of t, that is adding two signals even in the odd number of bits. So if we add this, it is no values is there, so we will get the values like this. If we add the two signals, if we add like this up to this, again we will have a phase shift here, that is it switches from 0 to 1, no, it changes. So up to here the value gets same, here also same, and here the value it switches negative, so like this.